So 1-4, I've broken down into three pieces, 1-4, A, B, and C. 1-4 is about how a graph behaves, and we're first going to talk about increasing, decreasing, or constant. Okay. So first let's talk about the word how increasing appears in a math. It's that the y's are increasing as we travel across the graph from left to right. Okay. You can kind of equate increasing with a line with a positive slope. So the y's are increasing as we travel across the graph from left to right. So then I guess you could probably guess what decreasing is. Decreasing are when the y's are decreasing. Look at the way I just spelled decreasing. That's better. As we travel across the graph from left to right. So we can equate that with a line with a negative slope. Now, our graphs aren't linear all the time, so we can't, but that's a good way to think about it. A positive sloping line is increasing. A negative sloping line is decreasing. So it's all about what the y's are doing. If I would walk across the graph from left to right, am I going up or am I going down? Is my height increasing? Is my height decreasing? So constant are the y's don't change, or the height doesn't change from left to right. This would be a horizontal section of the graph. Assistant speaking. Hey. Yeah, I don't see why not. Okay. 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 Yeah, no problem. Thanks. So let's take a look at a graph. And the way that I like to do it, it says here, where is the function increasing, decreasing, or constant? Okay. So I like to almost kind of color code it. Think about my silly little math book. If he's walking and he is facing the right, he has to go from left to right. That's the only way you can really gauge this. If he's going uphill, that section of the graph would be increasing. If he's going downhill, that section of the graph would be decreasing. So as you can see, if he's walking here up till this peak, his height is increasing. So I'm going to paint or highlight that section green. Now think about our math bug. If he lands over here, again, he can only face to the right. Now he would be going downhill. So let's make that red. And then this section, he's starting to go uphill again. So it is how the height changes from left to right. Is the math bug height increasing or is it decreasing? Now let's talk about how we're going to write this. We're going to write this with interval notation. So if you want to sketch the little graph, that would be a good idea. Okay. So let's assume this little peak is at -1 and this little peak is at 1. Okay, just based on how it's drawn there. Okay. So let's think about what we say. If my x starts from negative infinity, the leftmost side, my math bug's way down here, what x value will he be going upward or increasing until he has to stand at the peak? What at -1? So we're going to write -1. And we almost exclusively use parentheses for this stuff because at -1, that's that switchover point. So you're not really increasing, you're not really decreasing at that spot. That is a maximum or a hilltop, okay? So the x's will say where he's walking from negative infinity to -1. His y is increasing. The height. Remember, y is referring to the height. X is referring to going from left to right. Now let's think about the x value he would be walking from here to here, this section. The x values would be from -1 to +1. The y is decreasing. Okay. And then from an x value of 1, for the rest of his little walking career, so for the rest of his little walking, he is going to be going uphill again, so he will be increasing. So the thing that I've always told my students in the past, this is his walking path. The x is where he's walking. This describes his height. So the interval describes the x's. The word describes how his height is changing. So along these x's, my y is going uphill. Along these x's from -1 to +1, my y is going downhill, decreasing. And from these x's, my y is increasing. So the interval are the x's. The word is what the y is doing. Do you see how that works together? Okay, does that make sense how that works? Okay, let's go over to this one. And let's put our math bug always on the left side of the graph, looking to the right. And we can see that he's going downhill. He's going downhill. There's a little weird spot, but he's going downhill. So this is a type of graph which is always going downhill. So from an x value going to the left as far as he wants, to the y as far as he wants, the y's are always decreasing. And the functions, what made this graph is f of x equals -x cubed. That function is always decreasing. So if I put in x of 2, I get -8. If I put in x of 3, it should decrease again, -27. It does. So as he walks, starting at the left, negative infinity, to the right of positive infinity, he's always going downhill. So don't overthink these, but it's looking at graphs in a very different way, to prepare you if you do take those college algebra courses, if you do take a calculus course. We're really looking at the behavior of the graph. How is your height changing as you walk from left to right? Okay, everybody good with those first two? One more, and then we'll talk about the homework. So for this one, so let's think the leftmost side of the graph is, let's assume that's a little arrow on this side and an arrow on that side, okay? Now, you always put your little math bug on the left side of the graph looking toward the right, okay? So initially, what's he doing? Is his height increasing, decreasing, or flat, constant? It's increasing, right? He's going uphill. So I'm going to make that green. And then let's make the flat spot blue. Okay. So if we describe what's happening to the bug from an x value of negative infinity till an x value of -3, his height is increasing. Okay, does you see how that works? So from as far left as we want, negative infinity, to an x value of negative 3, the bug is going uphill. What happens to him at negative 3? What happens to him at negative 3? He's flat. He's on that flat piece. That's called constant. How long can he keep walking to the right? Infinitely. He can just keep going. His y is constant. Now, in mathematics, constant refers to a particular numerical value. We could even say that he is hitting a height of 2. Constantly, he's at a height of 2 for the rest of his little existence as he keeps on a trucking and walking to the right. So it is the movement from left to right. So let's go over it one more time. As my math bug starts at negative infinity, walks to a x value of negative 3, he's going uphill. But from an x value of negative 3 to an x value of infinity, he is stuck at a constant height of 2. Makes sense how this is working? Okay, so you're just breaking down the graph from left to right, okay? So your homework, you are just doing that. You're giving me the intervals, and their instructions are pretty crappy, so let me show you. Let's write a different instruction. I want you to determine the intervals. That's not the way it's spelled. Determine intervals. I don't think that's spelled right. Intervals of increasing, decreasing, or constant. So I want the x with the interval, the y with the description. Just like we saw in the examples, okay? So you're just giving me intervals. So let's look at number 1. So what I would suggest doing is drawing a very rough sketch of the graph, just so you can definitely see the x's, okay? So let's look at this first one. We really need to see 1, 2, 3, that's at negative 3. So make yourself a little xy axis. Make the little graph, okay? This side is going uphill. This side is going downhill. And that switchover happens at negative 3. So for an x value of negative infinity up to negative 3, my y was going uphill. And you can abbreviate increasing INCR is fine. And then for an x value from negative 3 to infinity, my y is going downhill. Okay? So that would be your answer. So color code your little graph if you want to use colored pencils. There's a big, that pink bucket has colored pencils. There's highlighters over there too somewhere. So draw a little sketch of the graph. Make your increasing section green, decreasing section red, and flat sections blue. We'll do blue, okay? And that's all you're doing for this. So there's only 8 of them, I think. So you'll probably get done with them pretty quickly. And that's today's assignment.